Hello, my name is Kelly Sneed.
And I'm Michelle Buxtaper.
And we'll be doing a presentation on ELISA and ELISpot. So just to start off with, antibodies are produced and secreted by B cells of the immune system, which have matured into plasma cells in an immune reaction. Each antibody has antigen binding sites which specifically recognize a portion of a protein or an antigen. Antibodies are utilized by the immune system to recognize foreign pathogens in the body so that an immune response can be generated to neutralize it. The ELISA assay takes advantage of the specificity and binding capabilities of antibodies to detect and quantify proteins in an experimental sample. So ELISA stands for Enzyme-Linked Immunosorbent Assay, and there are a few different types of ELISA. Direct, indirect, and a sandwich assay. For all types of ELISA, either the antigen or a capture antibody is immobilized on a plate, and an enzyme-linked antibody is used to create a measurable signal. In both direct and indirect ELISA, the testing antigen is immobilized on a plate, and an antibody-enzyme conjugate is used to detect the antigen. An enzyme is linked to the antibody so that when a specific substrate is added, the enzyme-substrate reaction produces a detectable signal. A detectable signal can be a color change, production of light, or fluorescence. The difference between a direct and an indirect ELISA is that there's an additional step in the indirect ELISA which uses a more general secondary antibody. Indirect ELISAs are more commonly used because they are more sensitive. Secondary enzyme-linked antibodies are less expensive, and a secondary antibody can be used for many different primary antibodies. A sandwich ELISA uses the same principles as a direct and indirect ELISA, except that it uses an immobilized capture antibody instead of a bound antigen. After the capture antibody is bound to the plate, a sample can be applied, and only the antigens that are specific to the capture antibody are pulled out of the sample and bind to the plate. A primary and enzyme-linked secondary antibody are then applied to the plate for signal detection. An advantage of using a sandwich ELISA over direct or indirect is that the sample doesn't need to be purified before testing, and it's very sensitive and specific because it uses 2 antibodies specific for the protein of interest versus 1. ELISpot uses the same principles as a regular ELISA in that it uses a bound capture antibody and a detection antibody to create a signal. The capture antibody for a specific cytokine is immobilized on the plate, and then immune cells are cultured on the plate. The cells are incubated with an antigen or molecule which stimulates the cells to secrete cytokines, and the target cytokines will bind to the capture antibody for detection by a biotinylated antibody. An enzyme-linked streptavidin and precipitating substrate is added, and the biotin-streptavidin reaction produces a visible spot that can be counted. ELISpot also has the advantage of being more sensitive than a traditional ELISA for secreted cytokines.
So here you see a chart of some of the parameters that can be controlled. So the first thing you're going to do when you want to use one of these is you're going to determine which type of ELISA you want to use. So a direct ELISA is obviously faster because it doesn't need an additional antibody for detection, but an enzyme conjugated primary antibodies are difficult to make and cost a lot. As mentioned earlier, indirect ELISAs are more sensitive and less expensive, and the secondary antibody can be used for many different primary antibodies. The sandwich ELISA offers the best advantage of being most sensitive and specific, and it removes the need to purify the sample before testing. And finally, the ELISpot is used to detect the secretion of cytokines and is more sensitive than traditional ELISA for this detection. So once you choose your type of ELISA, some of the things that you're going to control are the right capture antibody and the primary antibody as well as the secondary antibody. You'll choose these based on the specificity and the sensitivity, especially for the capture antibody and the primary antibody. Any non-specific binding here will lead to false positives, so it's really important to choose a specific antibody to your target. One of the other things you'll control for all of these is the immobilization technique for either the antigen or the antibody. You want on the plate before you even start the test. You definitely want a lot of stable binding. So you can do this by functionalizing the surface in any number of the ways. Further, it's important to optimize the washing in between steps. The detergent can be optimized to avoid washing away the target and therefore false negatives. It should be strong enough to wash away any unbound antibodies and antigens, but not so strong that it will wash away the target. So some of the important parameters to be measured are mentioned here. You're going to want to test any of the non-specific bindings. You can do this with a control with no target antigen, for instance. You also want to test the stability of the immobilization technique that you choose. You'll want to determine the upper and lower detection limits of your assay and the sensitivity in order to, before you begin the test. And then you'll determine a cutoff between a positive and negative result. This is a really important parameter that you need to determine before you actually go forward, because this is the result that these are the results that you're going to have to measure, and you're going to have to determine based on what you're seeing if this is actually positive or negative for the antigen or the protein. And you definitely don't want any false positives or negatives. And then you'll have to create a standard curve if you're going to be quantifying any of the antigen concentration.
Okay, so the type of data that you get from an ELISA and an ELISpot, the ELISA assays show whether a specific antigen is present in the experimental sample, and it can also show the amount or concentration of it in a sample. So you find the concentration by comparing it to an experimental optical density to a standard curve of known concentrations. And ELISpot can show the type of cell which is secreting a specific cytokine based on whichever cell you choose to use in your experiment. And it can also show the type of cytokine that's being secreted based on whichever cytokine you are trying to look for, the number of cells which are stimulated to secrete cytokines based on the number of spots that show up, and which types of molecules can stimulate a cytokine secreting cell, because you choose what you put into the cell culture. The specific type of data is either qualitative, positive, or negative based on spot development, and you can also get the number or frequency of cytokine secreting cells, which can show the magnitude or clonal size of the immune response within a larger pool of cells that populate more than one type of cell. Also, the size and sensitivity of a spot is related to the amount of cytokine released by one cell. So a darker or larger spot means that a larger amount of cytokine is released, and you can find this by using image processing software.
So just quickly to highlight some of the uses for ELISA and ELISpot in immunology. ELISA can be used to diagnose an infection by looking for either a specific antigen or an antibody that is present in the blood. It can also be used to quantify the amount of antigen or specific target protein in the blood to analyze disease progression using these biomarkers. Determining the antibody concentration is a good indication of antigen presence, and amount makes determining the treatment options much easier. ELISpot is used to determine if an immune cell secretes a particular cytokine in the presence of a certain stimulatory factor, and this can be useful in elucidating which cytokines are being released due to different signals and can aid in the development of treatments. Furthermore, an ELISpot can be used to determine if treatment with a particular drug can impact the secretion of cytokines in any way. And so some of the typical examples of how ELISA are used most commonly is to screen for HIV, West Nile virus. You can look at tuberculosis, rotavirus, hepatitis B, enterotoxin of E. coli, and many other things.
Thank you for listening to our presentation, and for more information you can go to these websites, and the last one is a manufacturing website with a lot of kits that you can look up their manuals to learn about ELISAs or ELISpots.